So nice to see you all here today. My name is Molly Larkin. I'm the Director of Operations at Fourth Brain, and we're so pleased to have you here at our community event today. I'd like to introduce to you Bruno Genoda. He's one of our longtime Fourth Brain instructors and an AI lead at Lockheed Martin. Bruno, feel free to introduce yourself and then take it away.
All right, sounds good. Yeah, hey everyone. So as Molly mentioned, I've been with Fourth Brain for a couple of years now and have taught many different workshops. Excited to dive into this one and talk a little bit about RAG, but not necessarily just kind of like the fundamentals of RAG itself, but more so on the operations side of actually tuning and monitoring and understanding various components of maybe more complex RAG workflows. But as Molly mentioned, so I am a AI lead at Lockheed Martin, so I have worked with a number of different end users over the last few years to build NLP applications as well as generative AI applications. So I'll share my screen and we'll jump right in. So we have a couple of slides just to kind of orient what we'll do today, and then we'll jump into a live demo for a majority of the session. If you have questions at any point, like we'll be kind of seeing the questions as they stream in. So if there's anything that you have a question about, ask it while we're there, and I'll try to answer if I can. If not, we'll round up some of the most common questions that we're getting, and we'll have some time at the end to answer those as well. But as I mentioned today, we'll be using weights and biases prompts, which is an LLM ops tool developed by Weights and Biases to help with logging, monitoring, as well as evaluating various workflows. So we'll talk a little bit about that. In the meantime, if you're interested in following along today, like we'll share the link to the Colab notebook that we're starting from. But kind of two important things you'll want to be queuing up between now and then is you'll want to have your OpenAI API key. So if you already have an API key that you can use, there's going to be a point in the notebook where you enter your own key. And then you'll also want to sign up for a Weights and Biases account. So I'll show you kind of what setting up your first project would look like, or if you've used it a bunch, what setting up a new project for this use case would look like. And those are kind of the two things you'll want to do if you want to follow along live. Otherwise, you're also welcome to just play this back later and follow along on your own time. All right, so as I mentioned, we're going to be diving into a use case today that is an interesting one because there's a couple of different steps to it. But it's following a tutorial that was written by Atharva Ingle, who's Weights and Biases ambassador and a data scientist. And there's a detailed blog post on kind of what was built, as well as a GitHub repo if you want to reference it here. But ultimately, the Gradient Dissent podcast is a podcast that's been long running for a few years that Weights and Biases runs. They interview all kinds of different AI ML SMEs on what they're doing and some key topics. But we'll actually be grabbing the transcripts from those podcasts. We'll be summarizing them to create some metadata within a UI that is maybe useful to reference later. And then we'll be able to ask questions against those podcasts. So as I mentioned, there's a couple of different steps. So we'll do like a multi-step summarization chain, for example, but we'll also have kind of the RAG component where we store all of this data in a ChromaDB and query it with GPT 3.5. So that's kind of the orientation. So if anybody's got questions, feel free to drop them in. But yeah, once we go to the Colab notebook, Molly, who you heard from just a minute ago, she'll be dropping the Colab notebook link, and then you'll be able to pick up right where I am. All right, so at a high level, we're a year and a half, 2 years into the Gen AI wave, so we won't spend a ton of time on the fundamentals of RAG, but for folks where these pipelines might be a little bit new to you, this is kind of a nice architecture of what's happening behind the scenes. So there's some stuff that you do, offline, and then there's obviously the inference side of what building a RAG pipeline might look like. But ultimately, this is the high-level workflow, right? You gather a bunch of documents. Sometimes this is already sitting in one place. Sometimes this is from multiple locations. Today, we have one source of data, which is going to be a series of YouTube transcripts. But you can envision in an enterprise application, you might have data living in multiple locations that you want to make all accessible via one interface, right? So you kind of gather all the data. A lot of times there's multiple formats. A lot of times there's some cleaning you might want to do to actually get the data into a good format or a useful format. So dealing with PDFs or dealing with, other highly unstructured data formats like, you got to get the data right. So you got to get the documents right and get the text extracted and prepared for the model to be able to actually leverage it. Typical next step is chunk the documents into smaller subsections. Often this is to deal with like, context window size constraints. There are some models, recently that have very, very large context windows, but a lot of times to be able to answer very specific questions, you don't necessarily always want to throw 20, 30, 50 pages of content into an LLM and hope that it finds the needle in the haystack. So a lot of times chunking up these documents either by section or in some creative way to, localize the context a little better creates a better user experience by being able to answer very, very pointed and targeted questions effectively. Once you have the documents chunked up, you'll pass them to an embedding model and throw them into a vector store. Now that you have the vector store, we're at inference time, right? So a user has some question, you're going to translate that question into the same embedding space, calculate a cosine similarity or some other distance metric. A lot of times you might do something like re-rank these results in some specific way. And then essentially provide the most relevant documents and the user query to an LLM as part of a template, and then have the LLM answer the question based on that retrieved context. So this diagram you can link to right below here. So we'll be sharing the slides out after the meeting as well. But you can link to that diagram. It's in the Hugging Face cookbooks, but it is a pretty good kind of overview of what building the RAG workflow kind of looks like. All right, so what are some of the common pain points? And that's what we're going to focus on today. What are the operational side of things that you might want to do to, either debug your pipelines, to monitor them over time, to do some of those workflows. So these are some of the common pain points. So like, when you have a multi-step chain, for example, so in this one that you see on the bottom here, there's an agent executor, there's an LLM chain, there's a couple of different tools. And the more steps you have in your chain, the more difficult it is to really understand if there's a complex issue in one step of the chain, or what data went into this, what output from step one went into step two, right? Like a lot of that right now it's either living in logs that you can access in a development environment, or it's looked at during development but not as often in production. So what Weights and Biases offers is a way to actually log like the runtime of individual steps in these chains, as well as the inputs and outputs of every step in the chain. Right. And that can be really powerful as you start to create more complex workflows. There's also other components of like evaluating, like, a new checkpoint of a model was released. Like, is it better? Do you have some reference data to actually go by and do that? So we'll kind of look at what this looks like, but this is all native to Weights and Biases, and it's very, very easy to set up in a development environment as well as a production application that you deploy. So the key features here are all the things that we'll kind of dive into as we get into the demo itself. But Weights and Biases Prompts, I think, is a good tool. There's a handful of others that are doing this kind of monitoring for not just RAG, but any kind of LLM workflow. But I do think Weights and Biases Prompts is a really good starting point for starting to build out some of these components into your projects. All right, so we'll jump into the demo notebook. So Molly, you should see the Fourth Brain AI post here. So this is the Colab notebook that we'll be starting from. I already have it open right here on this tab. I've only entered my API key. That's really all I've done so far. But this is the notebook that we'll be building on. So feel free to open that, and you should be able to run everything and just insert your API key and your Weights and Biases login credentials if you're prompted. But I mentioned we'll be using Weights and Biases, LangChain, tick token to like calculate and use the tokenizer for OpenAI, the YouTube transcript API, ChromaDB, and Gradio. So at the very end, we'll deploy like a lightweight Gradio app that you can kind of play around with and interact with the outputs of this model. So you can run that first cell. It'll take a second to install. You don't have to be on GPU. I'm on a T4 right now, but you don't actually have to be on GPU for any of these. You could pretty easily modify this to like run with a Hugging Face model, for example, like Mistral or Mixtral if you wanted to. And to do that, you would probably want the GPU for like runtime performance, but right now we're going to be querying the OpenAI API, so it should be fine on CPU as well. All right, so this is just grabbing your OpenAI key. If you're in VS Code, it would like, in the search bar at the top, it would prompt you to enter your OpenAI key there, or read from an environment variable if you already have it there. So once you get past this step, this is most of the setup. Now, here is the second part of the setup, right? So this is just configuring our artifacts for weights and biases. So in this case, you have to define a project name and an entity. This is your username or team within weights and biases. So I'm going to create a new one like now, so you can kind of see what this looks like. But ultimately, I created this, Fourth Brain RAG demo project name, and then this is my like username on weights and biases. But if I create this project, I'll be put in this spot here, and essentially this FB RAG demo is the project that I'm going to want to log to. So the nice thing with weights and biases is you can create community projects, you can have team organizations where like all of this is just easily discoverable by anybody that you're collaborating with. But right here under project name, I'm going to change this to the one that I just created, which is FB RAG demo. Try to spell it right here. So now anything that gets logged as part of this notebook session will get logged to this workspace. So you'll see I have a couple of other ones, like I was running this last night and just testing it. So that's this one here. But this is the one that will house any artifacts or any runs or reports that we create as part of this demo. All right, so if I run this is just gonna create some locations for where these artifacts might get placed and define the project name and entity. Most importantly is actually this step right here. So we're limiting right now to just 5 episodes. So there are way more than 5. I think there's like 200 something or 400 something transcripts that you can pull down, and you can run this with, you can run this on all the episodes if you want to, but that'll take a little bit of time. Just for reference, like when we're doing the transcript summarization, it takes about 20 minutes or so to query the GPT 3.5 API like 70 times or something, and get the results and do the truncation and the map reduce for all of that. So 5 is a nice number just for testing purposes, but if you wanted to run this on the full playlist, you would want to do that where you have a little bit more time, or you'd want to do that offline. So this is the data that we're actually going to be like pulling. So this is the playlist URL if you wanted to see like which videos are in there. So there's a bunch just for reference. So you can see there's 99 videos. We're limiting to just the first 5. So we'll be grabbing like these 5 here. But you can see that there's a lot more beyond those 5. And if you wanted to run this on the whole thing, it might be, an hour plus of just waiting for the one cell to do the summarization. So I will run that. And now, like, I'm already logged into weights and biases in this tab. So one of the nice things with weights and biases is that, like, if you just log in, like, it'll go and append my URL by noticing that I'm already logged in. But if you were, if you were deploying this and you had, a GitHub repo or something, like, you would have environment variables for your, for essentially your API key and your base URL for wherever the weights and biases server is that you're running on, whether it's a private instance or their public instance. So this is all running on their public instance, which is why you don't have to specify the URL or grab your API key directly, but it's able to just go get the API key if you're logged in another tab. All right, so I'll pause for a second. I know there was some questions coming in, so I'll see if there's any questions maybe to answer before we proceed to actually running through some of this. Looking back. So Sunny, you asked, like, when creating the embedding from our data, do we use the same embedding model as target LLM, or can we use any LLM to create the embeddings? Yes, that's a great question. So typically, you're going to want to have like the same embedding model that you're using to chunk your documents and embed them in your vector store as you're using for your query. Now, there are some ways to customize like how you have like joint embedding models. So there are some cases where you like might embed the documents a little bit differently than you embed the queries. But ultimately, your goal is to represent both the query and the document in a space or a vector space where you can calculate similarity and they're using the same embeddings or similar embeddings. There are some cases where like if you're using instructor, for example, where you might have like a slightly different instruction for embedding your query than you might for embedding your documents. But ultimately, you would likely want to use the same model for embedding both so that the similarities between them will be more similar. Cool. All right, so first step here, this is just like if you fail to get the YouTube object, like it'll just retry. So this is just a helper function to like retry getting the YouTube data. But importantly, like what's nice with weights and biases is that it enables you to do this work more reproducibly, right? So if you were just running like local to a Jupyter Lab instance on your machine or a VS Code instance or something, um, what can often happen is you might go run and grab 70 videos, or you might grab 30, or you might grab a bunch of videos or multiple URLs, right? You might save that locally and maybe edit your script or have like multiple places where things change as you're experimenting. With weights and biases, it's this easy to like create artifacts that can essentially make this entire script like extremely reproducible by, instead of like reloading the data, right? So if I were to run this script today and grab all the videos from the Weights and Biases podcast, and then a month from now, somebody else runs this and there's 2 more videos, and one of those videos is corrupt or creates an error or something, like they might not be able to run this notebook end to end, right? But instead of like re-pulling the data, they could instead point to the artifact that's already in the Weights and Biases project and say, grab this artifact, right? So grab the 5 videos that we ran today, instead of grabbing the latest 5 videos, which is what would happen if you ran this a month from now or a year from now. So artifacts just make it easier to make everything reproducible, right? So if you have kind of like, here's the data I pulled, and then for actually running my RAG pipeline, I'm pulling from artifacts instead of pulling from like a local data file. That makes it just easier for somebody else to pick up your code and like immediately be able to like run the same workflows as you were running and see the same results, right? Or the same issues or the same successes. So this is essentially like our data gathering process, right? So we're gonna grab the playlist URL. This is all baked into LangChain. So if you like go up here, there's a couple of imports that, it's on the next cell. Sorry for the scrolling. So there's a couple of imports that we're grabbing from LangChain directly to like read the URLs and grab the YouTube loader. So you can see this step right here is grabbing the YouTube loader from LangChain. This is the retrying step of like how many times we'll retry if we fail to grab the video or the transcript. We're getting some metadata. So like there's a transcript object output from that loader. So we're like loading the page content for the transcript object. And then ultimately we're adding this as an artifact in Weights and Biases. So as this is running, you can see it already grabbed those 5 videos. You can then go back to this workspace right here. And if you look in artifacts, you should see like YouTube podcast transcript. You can see the size of it. You can see when it was created. You have kind of like all that metadata just automatically stored and versioned. And then if you go to files, you'll actually be able to download that CSV that we wrote to a data frame. So this enables the next person to just like immediately go and run this with no issues. So is there a max size limit on the artifact? That's a great question, Faye. I don't actually know the answer to that. I'm sure that there might be, but I don't know the answer offhand. So that's something I could probably Google and see if there is a data size limitation on artifacts. What if there is? I think likely what you would probably do is like chunk this up into maybe multiple files and write each of those artifacts separately. So very similar to like what you might do with like GitHub large file store or something like that. Like at some point when you're dealing with data big enough, like you might want to shard it or chunk it in a certain way so that you're like storing these artifacts, near the maximum size limitation, but maybe not all in one single file. But it's a great question. All right, so we have that artifact. There's some other forms of storing this. So like if you want to store a table and actually be able to like look at that table in Weights and Biases and not just the raw file, this is essentially going to like write the data frame to a table object using this like Weights and Biases table modifier. So running this, you'll see it synced a couple of files. If I go back here, you should see this table now. And if I click in here and go to the latest, now if I go into files, you'll see this table, but you'll actually be able to see what's in it. right? So you'll see that these are the 5 videos, and we stored the title, the URL, the duration in seconds of the video, when it was published. So this is like the date that the video was published to YouTube. You'll see the full transcript here, and then you'll also see like the total words. So we calculated the total words just splitting on spaces. So this is like a rudimentary tokenizer, but all of that, you know, can be accessible. But if you want to actually view it in weights and biases, you have to store it as a table instead of an artifact or a raw file. All right, so now this is where it starts to get interesting. This is where we'll start to actually use some of our LangChain pipelines, right? So one thing you might do if you're building a tool or a product out of this is you might want to actually like summarize the transcript. And this is also a good example of like a chain that, you know, like might be a little bit complex to understand how outputs map to inputs and vice versa. So what we're doing here is we're like grabbing the data as an artifact. So this is like where this is going to be incredibly reproducible, right? Because anybody else that's running this, that's pointing to my same weights and biases workspace, will be able to use the artifact and not like pass it. Like they're not going to hard code like the path to a CSV file that's living on their local workspace. So this is just a nice piece of like making it all reproducible. Now, summarizing the episode itself, we're going to load the data with the data frame. We're going to split it using like the tick token encoder. So this is the OpenAI tokenizer essentially. And the way we're going to break this up is as a multi-step prompt. So we're going to do a MapReduce chain where we're going to essentially say, chunk up the full transcript into 1,000 token chunks, right? And then no overlap at the moment. So like we're just taking 1,000 chunks uniquely. And then we're splitting them up in that way. So like we'll have some number of documents for each transcript, right? So I think for the first one, it's maybe like 10 or 11 documents because it was about 10,000 tokens. And then what we're going to do is we're going to have like a map prompt. So this one is going to say like, write a concise summary about this short transcript from a podcast. And then at the end, we're going to have 11 of those, and we're going to combine all of them and say, in 1 or 2 paragraphs, summarize all of these summaries into a comprehensive summary for the entire podcast. And that's what these 2 prompt templates are going to do. So like one is going to do the individual summary for the single chunk, and then one is going to combine all of those, and then at the end combine it all. So to do this, there's a summarize chain in LangChain. There are multiple summarize chains. So in some cases you can fit the full context in and you can just do like a stuff kind of chain type, but there's MapReduce and there's 2 other ones. But this will ultimately say like, hey, we're going to do 11 queries, get the summaries of those, pass all of that into a second stage prompt that summarizes the entire thing in its entirety, right? So that's like this step. And then this is actually executing that and logging some of the metrics back to weights and biases, right? So the big thing that they've built, that weights and biases has built, is this tracer function, right? So for a summarized job type, like we're gonna get all of our data, and then this callback is essentially going to get metadata from the OpenAI response. And some of that metadata are going to be things like the prompt tokens, like how many input tokens did we have? How many completion tokens did we have? Total tokens, what was the cost of that query? And then we're also going to be like calculating the summary with that function we just defined, right? So we're going to have some summary. The output text is the thing that we care about of that summary. And then we're going to put that in the data frame and save that as an artifact as well, right? So this is the one that took a little while to run. You'll see like when I ran it last time, it cost like 10 cents. So it's a fairly cheap operation with the 3.5 API. If you were using the GPT-4, it might be a few dollars. But you can see there was like 67 requests. It took, I think when I ran it last, it took like 21 minutes or something. So keep that in mind if you are running this. Like it will take a little bit of time. For the sake of us not waiting 20 minutes for this to run, I'm gonna like jump over to a different notebook or I'll just stay in this notebook, but I'm probably not gonna run it all, or maybe I can just run it and hopefully it'll finish a little bit faster because the rest of the steps are actually much faster than that. But to show kind of the output of this, I might just jump to that other notebook since these artifacts won't be available in this workspace yet. But what I will show after one of these completes is I'll show like what the UI for looking at these traces looks like in weights and biases. And I got the question, I think, from Tommy, like, do I do workshops for weights and biases? I don't know. Like, I'm a user of weights and biases. I think it's a useful tool for developing this type of traceability as well as debugging some more complex chains. So I am a user not affiliated with weights and biases in any way. But I do think from an LLM ops perspective, like this is the type of thing that's going to be very useful as folks are deploying like agent-based workflows and they want to be able to debug, troubleshoot, improve, like upgrade from one model version to another, change the parameters to try to address, things like, are we giving enough context to the model? Should we increase the chunk size? Like those types of like nuanced details that, for a demo, it doesn't really matter. But when you get to, trying to operationalize it, like it does matter a little bit if you find that your pipeline is underperforming in some scenarios. I think weights and biases creates a pretty nice interface for doing that deeper level integration and investigation of model performance or pipeline performance. Yeah, so that's a great question, Raymond. So I'll say I've only used LangSmith a little bit. So LangSmith is essentially like LangChain's version of like observability for LLM workflows. I'll say I haven't used it enough to like tell you like this is where it outshines weights and biases or where weights and biases maybe has a better interface for doing that. But I'll say they are both doing they both have very, very similar objectives. So LangSmith is intended to be observability over your entire pipeline. I'll say like one difference is that like weights and biases does have support and integration for like Llama Index and LangChain, and I'm sure LangSmith will in the future have more integration for other libraries and stuff where you might be building like complex chains. But I think LangSmith is very much like built on top of LangChain and trying to create a lot of the same types of logging, reporting, etc. So I do think that they are alternative tools you could use for doing the same thing. I've been using weights and biases, back from even like the 2015, 2016 timeframe when you were running like parameter sweeps of a CNN and trying to tune parameters of a neural network architecture. Like, so I would say more familiarity with weights and biases than I have with LangSmith, but they do have, I think, a lot of the same core features. All right, so I think we just finished like our first batch. So like I mentioned, we had 5 videos that we were processing, and now we'll actually go and look at like what that looks like in weights and biases. So and yeah, so Faye, the purpose of the summarization is more so like later on, like that's going to be an artifact where you could actually pass this summary like into a UI. So you could say like, here's video 1 and here's a summary of video 1. And then you can, as a user, like it's hard to know, like if I go to let me see, do I still have? So if I go to the playlist, like, it's hard to know what questions you should ask of this u.com one with Richard Socher, right? So the summary, I think, like in the Gradio demo at the very end is going to give you a sense of like, what did they talk about? What were some of the key themes? Like, give me a sense of what was discussed. And based on that, I could try to ask a question of like, what might have been a part of that, like what was like a sample question that we're going to ask later is like, what's his perspective on the size of LLMs that the general population should be using for most Gen AI app development, right? And it'd be hard to know that if you didn't have more context about what was discussed or what content was a part of this. So the summary is more so like metadata to be able to understand what the episode is about. But to your point, the actual vector store that we're going to be using is going to include the entire transcript. So it's not the summary that's going into the vector store. It's actually the chunks of the full transcript. The summary is actually going to be more interesting to like look at the trace. So was more so like an example to specifically look at how all of this works. But so if I go to runs, you'll see the one that's running right now in weights and biases, they just create like these sample names with like a run 1, 2, 3, etc. So like they just grab random words and create a run name. But you can also name these if you wanted to name this like summarize chain. Like you could name it yourself as metadata before you run that cell. But if I dive in here, what you'll see is a table, and you'll essentially have like different traces for each run, right? So if I go back to the notebook and I look at this chain, so this is one chain, so this will run one time for each video that we process. But within this chain, we know that there's anywhere from like 8 to 11, map prompts and steps, and then there's going to be a combined step, right? So the summarized chain is, I think, a good way to just kind of like look at a multi-step chain in a pretty intuitive manner. But what you'll see here is this is the trace timeline. So you'll see the total time that it ran. You'll see how long each individual step took, right? So you'll see that there was, in this case, 13 map steps, and then, there was 11. But for each one, you could actually investigate. So like if I click on the sixth one, so if I click on the sixth one, you'll say, here's the prompt. So write a concise summary. And then the chunk that was input was essentially this part right here, right? So this is going to be like the 1,000 token chunk. And then it ends with this concise summary. And then the actual output was right here, right? So it discusses the creation of a platform at Mayo Clinic that allows the sharing of de-identified health data, et cetera. So like that chunk was talking mostly about that topic. And then you'll also see some metadata of like what model was used, whether or not you streamed the results, the temperature setting. You'll see this token usage, right? So like how many completion tokens were there? How many input prompt tokens were there? And this kind of makes sense. Like our template was 43 tokens, and then we added 1,000 chunk token. And then there's, you can calculate or derive cost based on that. But this is the kind of like just nice, like go dive into the details of it stuff that, because the logging is pretty lightweight to do, like it's only adding a couple lines of code to like any notebook that you build. It makes it way nicer to go back to something that was done 3 months ago and understand what was done, how it was done, what model was used, all the details that can be easily forgotten sometimes when you're rapidly prototyping or when you're iterating on different topics. So, and you can see like this is just one where we like call the chat OpenAI API a bunch of times, but like, if you had tool usage, if you had, like a SQL agent that had to generate a query, and maybe there was a step to like do self-correction where if that query, encounters an error when executing in the SQL environment, you like take that error, take the query, re-ask the model to self-correct. Like these are things that like are nice to be able to have the visibility into, right? So as you kind of get into more complex use cases, this becomes even more powerful. But even from a visibility perspective, like all we saw is that something was running so all we saw was that this cell was running for 3 minutes, but we don't really have like a good sense of the individual steps, inputs, outputs, all of that, right? So that's where it gets pretty useful. You can go back. If I refresh this, I think we should have a second one to look at for the second podcast. So 1 of 2. So you'll see like this is the second one now, where this is that second video. And again, it's all interactive. So you can like click on this and it'll, take you to the individual steps for this one. And you can, maybe look at like an interesting one to kind of look at is kind of that last step, right? So the last step being like, here's all of the, sorry, it's like hard to get to this second layer. So 15 here is like the final step where it's, you've been provided a summary of chunks of transcripts and your goal is to merge all of these, and then this is kind of where you get like summary of chunk 1, summary of chunk 2, and so on and so on, right? So this is that final prompt that goes in, and then the overall summary is kind of here at the end. So you can see the total size of this is about the same size, right? So the prompt is much longer in this case, or maybe not much longer, but this is, in this case, passing in like 11 distinct summaries and then getting some total output at the end there too. All right, so I'll keep jumping along. So now that we have kind of the summaries, that's going to be useful metadata. You can log that as a separate artifact. The next step is kind of embedding, right? So we talked about getting the chunked up full transcript, right? So this is, again, we're using the same 1,000 chunk size. You don't have to use 1,000 as a default. But in this case, we're just going to use the OpenAI embeddings, put that in a ChromaDB, and then persist that DB as an artifact, like within the weights and biases instance. So this runs much faster. I think this only took less than a minute, and you can see like near zero cost. So like a lot of trailing decimal places because embedding is cheap. But once we have the embedding, that's when we can start to ask questions against this and build a chain around it. So the actual like weights and biases chain that we end up storing. So like you can store the prompt template. So that's one where if you're iterating on the template, you can kind of have like better visibility into like incremental prompts that have been tried. You can also do like iterative evaluation and stuff, but you can even see like, hey, like we're hard coding in this case k equals 2, but if we try k equals 3, k equals 4, k equals 5, like you can almost have like a nice visual of like what that does to cost and what that does to performance on some reference data set if you're using like a framework like Ragus to actually evaluate your prompts. And there are some nice tutorials that Weights and Biases has developed on like using Ragus and actually iterating on different checkpoints of the 3.5 model, or using different parameters for k, or different temperatures, for example, and actually getting like a table summary of like which configuration works best. But this is the chain. So we're essentially doing like just a retrieval QA chain with source documents, and then we're also querying any of those pieces of feedback back to OpenAI as well. So you'll have like queries and questions, and you'll have a result database that shows like what context was provided, the full prompt, how much it costs to answer that question, all of that. So I'm gonna like run these cells, and hopefully this one finishes and we can get to that live demo at the end of the Gradio interface. But I'm just gonna run ahead and let that kick off. But this was the question that I ended up asking. So the power of AI in search with U.com's Richard Socher. So you essentially tell it like, get an answer from this video, right? And in the actual Gradio app, like you can select like from a dropdown which video you want to ask a question of, and then like go ask whatever question you want. And to log all of this, it's literally just these two lines here. So this, and then in the function for get answer, we're logging certain inputs and outputs for the tracer. But when this runs, we'll actually be able to see kind of an example of what like an individual question answer pair looks like. But I'll pause for a second and see if there's some other questions that I can answer while we're waiting for this to run. Yeah, so Jamie, so I don't know if there's a summary. I do know for like Gradient Dissent, specifically for their videos, like they tend to, like if I just pick one at random, they tend to like put in the notes here, like details of the podcast, and they have this. I think that this is like auto-generated. I don't think that this is based on like a user actually annotating all these timestamps, but you can see like that's how those sections get split up. And my guess is that's all metadata you could probably pull from the YouTube API. So like that summarization step probably isn't critical for like making an application like this useful to people. But you can envision a scenario like, I don't know, like I work at a large Fortune 100 company. Many of you might as well, but like, we have internal trainings and webinars and, like internal non-YouTube video sharing platforms, right? And you could run and create a lot of that metadata with LLMs. Obviously, it could be costly if you're doing it all with cloud resources, but you could also do it with local LLMs that, that can do similar things like summarize chunks of text and stuff pretty effectively. So you could use Gemma or you could use Mistral, for example, to like do that summarization chain and do it all on-prem and do it all locally, even if you had, a decent GPU workstation. But my guess is like YouTube probably does have some services to do things like auto summarize your content and provide that back via API. I just don't know specifically, but I will tell you that like any kind of like internal streaming or video sharing platform to a large company might not have the same level of robust features. Yeah, so Fei Wang, to answer your question on what my experience has been with different databases. So vector databases are interesting to me. There's a lot of I'd say that there's a lot of good tabular summaries of people comparing features and robustness, and can you run this in a disconnected environment? How scalable is it? Like, do you have multi-node tenancy and all these other factors? I'll say I'm more of an AI ML SME. I'm not like a database expert. So like I've used a handful of these and I have, thoughts on like Fias is great for prototyping. It's super easy to like quickly throw it together. ChromaDB I think is also really great and you can persist it and it has some additional features for like different types of similarity calculations. I'll say my general opinion is like if you are building like a large enterprise strategy that involves RAG over many, many types of documents, like we've done some trade studies on comparing like the features of all the different vector stores, and Weaviate tends to float to the top as being the most feature rich, the most performant in some cases when you start getting to the tens of millions plus documents. But to be honest, like I honestly think it depends on your infrastructure, right? Like if you have a bunch of people that are really good at Postgres and you do a lot of stuff in Postgres, PG Vector is a great solution for you, right? Because you're already gonna have the skill set on the team to go do that stuff. I would say like most AIML teams kind of follow the tutorial, and if it's a ChromaDB and it works fine, they just kind of do that. I think Chroma is nice for prototyping. I think Weaviate is nice for like larger enterprise scale production applications. But I would say I'm not heavily opinionated on like each individual one. And I do know there are some people that have like I had a tab open at one point that had like just a really nice like comparison summary of all the different vector stores. But I could probably try to look that up in the background if I can find it. But yes, I will say that there are a lot of options out there, and they are, in my opinion, very lightly discriminating. Like I think a lot of them have a lot of the same core features, and then there's kind of very minor nuanced things. Like this one supports multimodal models a little bit better than this other one that doesn't support, storing, matrices instead of just single vectors. So like there's little tiny things that I think make up differences between them. But my general opinion right now is Chroma is great for prototyping, maybe even great for smaller scale applications where you need to persist the vector store locally. And Weaviate is a great option if you're doing like a centralized like hosting version of it. Yeah, so Lewis, that's a great question. So that's what this is intended to be about, right? So like if you have some process to determine whether or not the answer to a question is factually correct or consistent or something to that effect, it is useful to be able to go find like where it's wrong, right? So right here when we have our like RAG component, so right here where we're actually like asking questions against the summarized documents, right now this is just going to say, hey, like return the result and the answer, right? So this is like the function to get an answer, maybe to deploy it as the beginning point of like an API endpoint or something that integrates into a user front end. But you can envision a function that looks just like this, that's like evaluate pipeline, right? And you'll have a bunch of sample questions that get inserted in this prompt, get asked, and then you'll have question, answer, and model response, right? And then you could do stuff like use GPT-4 or use a power model to like, try to understand like is the model's generated answer and the reference answer, are they semantically similar? Are they correct? So the most common framework for doing this is called Ragus. So this is like specifically how do you calculate more robust metrics when you're building RAG pipelines, right? So they have an evaluate function, and let me see. Yeah, so like there's a Ragus score that looks at both like the quality of the generation and the quality of the retrieval, right? So did the right document get retrieved? Did it retrieve all the necessary documents to answer a particular question? And then there's other metrics for like how relevant is the answer to the question, how factually correct is the generated answer, and some of these are like, like you're using an LLM as the evaluator. Some of these you can actually try to calculate some metrics like some of the retrieval ones, like if you know that the answer should be in document 7, like document 7, is it in the top 3? Like that'll give you a sense of like the precision or the recall metrics. But what I've seen is people use metrics like semantic similarity of like, here's a reference answer and here's the model's answer. And like, based on how similar those are, you can actually look at like configuration 1 and configuration 2 and see like, is the semantic similarity between the reference answer and the actual answer higher for one configuration of the model that maybe uses a different embedding model or a different chunk size or a different number of K retrieved in the pipeline, right? And you can actually start to like objectively say this configuration might be better than this other one. Now, is it easy to trace that back to like a retrieval embedding problem or a transcript issue? Not always, right? So in general, like you can go look and see like, I know this answer should be in document 7, but document 7 didn't get pulled in as one of the most relevant ones. So you can go look at like, what's the semantic similarity of the relevant chunk to the query, right? And then you could do things like, what are other ways to ask this question that, yeah, I'll say you can get pretty deep into the debugging. So we've built some notebooks that like, when you find a scenario like that, you essentially like query GPT-4 to permute the user's question in like 5 or 10 different ways and see if there's any framing of the question that improves the downstream answer. And what that might mean is that like what you want to do to add robustness is actually like do a multi-query approach where a user asks a question and you reword that question in a couple of different ways and do like a async prompt. Now, again, that adds costs. So like if you're in a cost constrained environment, you probably wouldn't do that. But if you're running some of these models on-prem and cost isn't a big factor, like you can do something more robust than that. And that would be a way to like mitigate some of the issues that you're detecting on the retrieval side. But what I've seen is there's a lot of solutions that add complexity to pipelines that are easy to implement, and people throw it in and they're happy when it works, but they're not maybe optimizing for cost at the same time. And I think some of this can be derived a little bit more effectively when you're tracking and monitoring like your evaluation. So short answer is like, yes, you can try to understand like cost at that level, but it is and correctness or accuracy at that level, but it isn't always straightforward. Okay, so it looks like that notebook we were running like is finished now, so I could show like it's gone through and embedded. If I go back to like the artifacts, you'll see so you'll see at the top level for artifacts, like there's a couple of additional runs now. And then if I go here, you'll see there's like the data set side, and then there's the history, and then these are like actual queries. So like this is the summarization step, this is the transcripts, the raw transcripts, and then each of these are like individual queries. But this is where you can actually go and like for an individual query, so the most recent one that I just ran, it took 26 seconds to return a response. And this should be like the single question where I said, what are Richard's thoughts on LLM model sizes? You can see what the output was. But if you drill down in here, you can also see like what documents were retrieved. Sorry, the interface is like a little bit messy, but you can see like this was input document 0, input document 2. So like these were the chunks that were retrieved, and the full prompt that was provided was essentially here. So using the following pieces of information, here's the context that was provided. One of these, like, he does talk about model sizes. So this is what was left, and then this was the user's query that was input. And you'll see that the answer you get back from that is Richard believes that for most enthusiasts, a 7 billion parameter model that's been fine-tuned, et cetera. So like he answered that question that way in that video. And you can see like the cost and some of the other metadata that gets logged automatically, right? So having this just be part of your API, like this is a very minimal cost to have like more detailed logging and metrics for like any RAG pipeline that you're deploying. And ultimately that's the goal of this, right? Is like getting beyond kind of the experimentation and to the operational side of things. This last cell, if you want to run it, this is going to actually take like the original blog post like made their artifacts public. So this is actually grabbing like all of the, like this is grabbing from the public repo that was originally in this. It's grabbing all the videos, all the transcripts, all the summarized artifacts. It's creating a couple of functions to like create a Gradio UI. So if you haven't used Gradio, it kind of looks like this. Like you can create Markdown and you can build like a little lightweight app. You can have rows and columns and different drop downs and other options. But and you can actually take like, hey, like when this button clicks, go do this, right? So you can launch this and it'll stay up and running as long as this cell is running. So as long as you're running this in Colab, it'll run, or you can deploy this as a Hugging Face space. It's no longer running on the Hugging Face space that this blog posted to, which is why I like copied this in to like run it locally. But if you run this last cell, this is what the like end state application of that tutorial was, right? So it's a Gradio interface. You have some markdown describing what's here, links to the repos, links to the report that was written. But this is where you can actually like go select an episode. Now, I think at the time this was run, I don't know if the video that like we were just looking at with Richard Socher was already in this index. I don't see it. But you can pick another video like this Jeremy Howard one, and you can get the podcast info. And this is where that summary comes in. So this is like that 2-paragraph summary that was run with like that MapReduce summary chain. This is the embedding of the actual video itself. So you can see that you can play this from within the Gradio interface. And then they also had a step where they like, essentially created like, what are some sample questions you could ask of an individual chunk? And then, like you can copy one of these and actually interact with it and see like, what would the model respond based on the RAG pipeline that's using the full vector store in the truncated. So maybe not the best live example because it looks like it didn't retrieve the right context to answer that question, but this is what the full application looks like. And you could probably reproduce this if you just run the full thing and point it to, in this last cell, instead of pointing it to the public artifacts, like you could point this to the 5 artifacts that we specifically created. And then you could run it and it would be based on like the data that we were experimenting with prior to that. All right, so I hope this was useful. I'll look and see if there's any other questions that I can try to ask or answer here. But I'll also point out that like, if you found this useful, or if you think that this type of content is interesting, like you're welcome to go back and look at any of our upcoming workshops. So the last slide here kind of has the link to the Fourth Brain programs. I think this one, if you're interested in LLM ops, like we have a cohort coming up in a few weeks on LLM ops. And, week 2 is all about building out advanced RAG applications, doing things like answering that question that you asked, Krishnam, of like, what's the best way to work with PDFs when you have complex tables or other mechanisms like that, right? So what are the pre-processing steps we can do to like go, actually create useful vector stores with complex PDFs? How do we use weights and biases or other tools to like evaluate one configuration versus another configuration? So we also have other workshops that are not specifically tied to RAG that go into deep dives on fine tuning or go into deep dives on prompt engineering and building different types of workflows with LLM. So Yeah, I mean, we've been deep in the space and we love sharing some of this content. So if there's anything that you liked or didn't like about this workshop, like definitely let us know. Um, but yeah, I guess we have a minute or a couple minutes. Molly, I don't know if you want to add anything else, or I can also look back and see if there's questions I didn't get a chance to answer directly.
No, you took my lines, just letting everybody know that we have some workshops coming up next week. There are a couple more questions that I think we have a few more minutes. So there's a couple questions about chunking. So Krishnam asked, what's the best chunk strategy for PDFs with tables?
Yeah, so that's a good question. I would say I think Llama Index has been fairly invested in RAG specifically and like building good RAG workflows. So they have like a see if I can find it live. Oh, there it is. So multimodal on PDFs with tables. This is like right now what I would say is arguably the best way to think about getting useful data out of maybe more complex document types. So like Microsoft has a model called Table Transformer that like specifically detects tables within images and then extracts the components of that table and then uses GPT-4 vision to like take that table and actually put into words what's in that table. Right. So an example is like if you had a table for Gemma where they're comparing their performance on MMLU or some other benchmark, like it would take that table and say this table compares the Gemma model and several other models and insert model name here and shows that it's more performant on these tasks and equivalent performance on these tasks. So it'll take that table and actually add like metadata into the data that you can store in your vector store that essentially like helps you potentially answer questions that leverage that table. The other angle that I would potentially look at is there's a library called PDF Plumber. And this one is also a nice library that is specifically targeted at getting data out of PDFs and specifically targeting at getting data out of things like tables, right? So they have different mechanisms of doing this, but essentially you'd get like a location of here's every table in there. But I'm trying to see, they have like a nice graphic of like what their parsing strategy looks like, but this is kind of what it might look like, right? So you have PDF page 0 as an image, you have it like this, and then it'll actually extract all of these like elements and keep the structure the same. So it'll like take like, hey, row 1 of the table has this date, this effective, this received, this company, this city, etc. So these are probably the two that I would look at if you're like dealing with complex RAG and trying to build out like better pipelines over messy PDFs. Yeah, so PDF Plumber and then using GPT-4 Vision if that's available in your environment and you can share your data with OpenAI or with the Azure Pub Cloud or wherever you're querying that model. But yeah, either try to use Table Transformer to find the tables and then take that image and pass that to GPT-4V, or use PDF Plumber to like essentially do like robust OCR over components of the table and keep the structure in the output consistent.
Great. Those are two really great resources. There's one other question that I think we should get to because I think it's important from Jeff. For LLM ops functionality in production, how do you use the weights and biases output to help enhance the solution from these different perspectives?
Yeah, so I'll say there's different ways to do this, right? So I mentioned like there's using it during development to try to pick the right model to deploy, right? So that's like step 1 is like you as an engineer actually inspecting the runtime of different chain configurations, whether or not certain steps are necessary, and doing kind of that interactive debugging. So that's like one way to use it to like build a good model. The second way that I would use it is I would say like for a deployed solution, what are the important things to log and to understand in your deployed applications, right? So one way to use it is to log traces. Maybe you do it in batch. Maybe you don't log like every trace for every interaction that a user has in your application that leverages RAG under the hood. But maybe you batch and say like, hey, 1 in 10, go run this through an evaluation pipeline that outputs the trace to weights and biases and actually looks at things like, did it answer the question factually? Did it pull in the most necessary context? Like you can manually define that or build secondary models to actually automate portions of your evaluation pipeline. or you can use libraries like Ragus to log some of those metrics back to weights and biases. And you can envision a scenario where 3 months from now, you have maybe several thousand queries in your database, or maybe tens of thousands or hundreds of thousands, depending on the scale of your deployment. But you'll also have a table of like, what are the underperforming queries in terms of like your evaluation pipeline determined that those questions weren't answered effectively, or maybe user feedback in your app where they put a thumbs down. Like you can log all of that to weights and biases and have a table summarizing the cases that right now your model is underperforming on, and have a development team in the background actually trying to understand like what went wrong, right? Like, did we not grab the right chunk? Did we, did we like run this secondary step and that errored out? Like it would, like there's ways where you can actually output like the debug, the error message, and any other components of that, like in weights and biases. So that's how we have thought of and have used weights and biases. Like there's using it for development and then using it for evaluation and production inference, like actually logging some of those evaluation steps and pipelines to weights and biases. And there's ways to do that, like in Fast API, there's like async processes where you can return a response to a user and then have an async process that like is a queued batch mechanism to actually do evaluation on that sample, but it doesn't affect the user. It's like a background process that runs when there's resourcing available. So we've done that where we kind of log some of those performance characteristics like back to the database, so that the engineering team has essentially a hit list of like, here's the things that you can try to build out better because they were underperforming, and here's the trace, and here's the actual steps, here's the pieces of the prompt that weren't working. But the short answer is I think a lot of this is still kind of being figured out. So that's a design pattern we've used, but maybe not the only way to leverage an application like weights and biases.
Yeah, and just to add, at Fourth Brain, we are, moving more into LLM ops and trying to see and teach more of that. So we do have a workshop coming up. We also will be having more events focused on ops, on the ops side. So definitely keep your eyes open for that. We're a little bit over time, but I do think we should answer this one last question from Chris. The Gradio demo didn't fetch the right chunk. How do we root cause that error using weights and biases?
Yeah, so I think I stopped sharing. Let me share out real quick because I don't think I can answer it without actually looking at that window. So give me 1 second. So you're saying the case where right here, right? So you're saying like this case, I said, what is the best way for data scientists to make an impact in their work? And the answer was not relevant, which means that maybe the reference chunks don't actually answer that question. So how would we go and discover that? So it's a good question. So I'm going to look back at the notebook, and I'm just going to make sure that we actually are logging the traces for this. Okay, so we are. So if I go back to, I think this run, so nope, not this one. So if I go back to workspace, and it might actually be easier to like run a new prompt. So like I'm gonna just rerun this one so that maybe it'll create like a new run. So okay, so we got, I'm sorry, this question is not relevant to the provided context. So let's look back and see if we can find that in our runs. But my concern is, let me see. So I have to just check if we are writing this. Okay, so I think right now I was logging this to this. So like the project name that I have is FBRAG demo. So not this one. So I'll go back here actually, because in the app, like this is logging, I think, to like the public like Gradient Dissent QA bot weights and biases project. So I'd have to like go find that and find the run that is associated with that question. But I can probably test it right here if I just ask a question in here that's not relevant, right? So if I ask like, who won the 2024 Super Bowl? And if I just run that, of course. Oh, sorry, the get answer function. Sorry, this is live, but the get answer function was like different. I overwrote it in the Gradio app because it had the same name. So I get an answer of I don't know, which means the retrieved context didn't have an answer to this question of who won the 2024 Super Bowl. So if I go to like my environment now, and if I just refresh, I should have like something after Hopeful Breeze. So I should have like a sixth run name here. Unless it's still right into this. Let me just see. Okay, so Hopeful Breeze is the run for like all of these, for this pipeline essentially. So that get answer pipeline. So actually, you can see that other question here too. So I thought we were logging to the other table, but we actually are running this and writing it to the same workspace. So this is like the 2 times I asked that question and got that the context wasn't relevant. So how would you actually go do that? So you could click on one of these and then go look into the this chain, and like you'll see, like this was the input document, right? So the input document in that prompt. So if you go to like this last step, this is like the actual prompt that combines all that context. So this was the prompt, right? So use the following pieces of context to answer the question. Now we have it set to like k equals 2, but there's ways to like set this up in a more robust manner. So right now, like we're grabbing the 2 most relevant chunks in this transcript that are relevant to the question, right? But we don't have any like thresholding on that. So there's a way that you could say like, hey, grab the 2 most relevant chunks and k equals 2. But you can also say grab the 2 most relevant chunks, but make sure that the similarity between the query and that chunk is above some threshold. So it's essentially saying like grab only chunks if there's similarity above some threshold. So that's like a simple thing you can do in production to say like, you know, like you just got an I don't know, but you can actually like say like no relevant documents pertaining to that question exist in this vector store. But these are the chunks that were retrieved, and you can see like none of them even mention the Super Bowl. So when we say answer that question based on that context, the answer is I don't know, because we've told it to say you don't know if there isn't a good answer. So this is how you would actually like go and look at that step. Like you would go and say, okay, like what was the retrieved context? You'd have to manually review it and see, do I agree that there's no way to answer that? And if you do, you know, and you could also like send that to an LLM and say like, you know, why isn't this answer questionable based on this context? And you can, you know, have metadata that's like a secondary output of like 4 cases where the answer is I don't know, or the answer isn't a specific response. Like you could have a chain that says like for those cases, actually try to like write out separately like the reason why that data isn't relevant or whatever it is. So you can kind of like add whatever level of complexity you wanted to that, but that's how you would do it. You would go look at the actual run number, go look at the last step in that run where you're combining all the inputs from the retriever, and then go look at the actual context and see if it mentions Super Bowl or mentions anything specific. But thanks for the question, Chris. That's a really good one.
Great. Bruno, thanks for answering all those extra questions. For everybody else who is here, thank you so much for attending. Definitely check your email later today or tomorrow morning. I'll be sending out this notebook, the slides, the recording, and then some links to some of our workshops and upcoming events, just so you can, you know, keep abreast of what we're doing over here at Fourth Brain. Thank you all again for attending. Bruno, thank you so much for this really great tutorial. And we hope to see you all soon. Have a great rest of your Friday.
All right. Thanks, everyone. Have a great weekend.